So just remember, if there are conditions, we should do those first. Let's see if they break up into cases. Now, this next one may be a little bit different from the previous. I use car a lot. 7 different car models are parked close to the street for easy viewing. The 3 red cars must be parked so that there is a red car at each end of and the third car parked exactly in the middle. How many ways can 7 cars be parked? So right away, I'm just going to go A, B. So these are just going to represent cars or letters. It doesn't really matter. And then I have other cars here that don't really matter, the color. So that's 6. And one last 7. There you are. And maybe F will be gray, sparkly gray. So now I'm just going to park my cars. So I'm just going to say, I'm going to park 7 cars. I'm just going to put 7 different spots. 1, 2, 3, 4, 5, 6, 7. Now the difficult thing about counting is, when is it a fundamental counting principle? When is it cases? What are we talking about here? So I always like to visualize what we're doing. So here are my 7 spaces, presumably in a row. And I know that these last 2 have to be red. So I have to park a red there, and I have to park a red there. So red's parked on each end. The third car is parked exactly in the middle. So there's our middle placement, and we have to have another red car. So what I see from my elements, I have 3 red. So let us deal with those conditions that we must meet first. I'm going to choose, where am I going to park, how many options are there for the first spot? Well, there are 3 red elements, A, B, and C. So I'm going to park one of them. Now I'm going to park a car in the middle. 2 different options. Now, isn't it interesting that at the last, it is a given which car I park? Only one option. So now there is no other conditions based on those other parking spots, so I get to choose any of the 4. So how many spaces can I put in the next parking lot? 4. In this next parking spot, 3, 2, and 1. So I'm just going to take out my calculator. So here, I would actually use the fundamental accounting principle because that's what makes sense in my head. And what I get is that there are 144 ways. Uh-oh, hold on. Let me do this again in my calculator. 3 times 4 times 3 times 2 times 2, and what I get is 144. There we have it. Now let me go on to this next question. 3 cars must be parked side by side. So I'm just going to draw my elements A, B, C, D, E, F, and my fancy one, A, B, C, D, E, F, and G. Sorry, for my previous example, I guess I had 2 C's. So those are my 7 cars that I need to park. So I'm just going to here's the trick. When you have to group, how would you say these cars? How are we going to park these cars? You're the boss. How would you give the command? Well, you would say, hey, let's take a look at the red cars first. Let's park the red cars. And by the way, we can only park the red cars together. So what we're going to do is we are just going to treat these as an element. We're just going to treat them as one blob. And now this is 1, 2, 3, 4, 5 things we need to park. So instead of 7 spaces, I'm just going to put 5 spaces. So now I have 5 elements that I'm going to park. The red block is just simply one element. So it's 5 factorial. So if you think about it, if you just put the red cars all together, they act as an element by themselves, and you're just arranging 5 elements. Now here is the thing that you have to remember. The red cars can also be parked in any order. So how many different ways is there to arrange these red cars? Well, it's 3 factorial ways. So what I get is 5 factorial times 3 factorial. I get 720. Now you may have to do a few examples like this, but I would say when we're putting elements together, just make sure that you put them together and you create a new element, and I'll put air quotes around that, a new element or new object with these 4 things, and then you're just simply going to play it. So this is the arrangement of those 5 elements, and this is, I would almost consider, the unwrapping of those red cars. How many different ways can we arrange the 5 elements? Well, 5 factorial ways. How many different ways must we arrange the 5 cars? Now, watch. I'm going to arrange 5 elements. I'm going to group them together. And then arrange red cars. Now, my penmanship is very poor here. So basically, I'm going to arrange the 5 elements, which is 5 factorial. And then, do you remember earlier I said then really implies a multiplication? And then I'm going to arrange the red cars. That's why we multiply these 2 things together. Good luck.